Assalamu alaikum. We have learned that a vector can be resolved into its components. What is the meaning of resolve? Resolve means splitting. So a vector can be splitted into its components along x-axis, y-axis and z-axis. Clear? Now in this video we will discuss a very important property of components of vector. What is that? I'll try to explain this with the help of an example. For example, I've got two vectors, vector A and a vector B. If these two vectors are equal to each other, then their components will also be equal to each other. Let's just see that. First, I am going to resolve vector A into its components. Vector A have a component along x-axis given as AX. AX is the component of vector A along x-axis, and here the unit vector along x-axis is I cap. Then the component of A vector along y-axis is AY, and the unit vector along y-axis is J cap. The component of A vector along z-axis is AZ, and the unit vector along z-axis is what K cap. Here unit vectors have got magnitude equal to 1 and they act along x-axis, y-axis and z-axis according to the position of the object. Okay, and from this we understand that if we multiply something with the unit vector, only that object or that magnitude or that term gets direction, but nothing happens to its value. Now, this is quite known to us. Now, by keeping this in mind, I am going to split B vector into its components. B vector is written as Bxi cap, By j cap, and Bz k cap. Here Bx is the component of B vector along x-axis, By is the component of B vector along y-axis, and Bz is the component of B vector along z-axis. And here I cap, j cap and k cap represents the unit vector along x-axis, y-axis and z-axis. Clear? And they provide the direction to the components. Now, as mentioned here, by keeping this in mind, here A vector is equal to B vector. Now, in the place of A vector, I write their value. What is that? Nothing but this. Axi cap, Ay j cap and Az k cap is equal to Bxi cap, By j cap and Bz k cap. Got it? Now, I am going to compare the terms present on the right side with the terms present in the left hand side of this equation. So, if both are equal to each other, then yeah, Bxi cap will be equal to Bxi cap and Ay j cap will be equal to By j cap. In a similar way, Az k cap will be equal to Bz k cap. This is what it means. Now you would have understood that if two vectors are of same type, then their components will also be equal to each other. This is what we understand from this. Now we'll solve a numerical problem relevant to this. Okay. Now here the question given is compare the components for the following vector equations. Here two equations are given. One represents the force, another represents the momentum. Okay. First I'll start with the first equation. I'll take this. F vector is equal to m a vector. Here m is a scalar quantity which represents mass, and it is a positive number. It has got positive value. Clear? Now it can be resolved into its components. How? See, first I will resolve f into its components. Component of f along x-axis is fx, and here the unit vector is I cap. Component of f along y-axis fy, and unit vector is j cap, and the component of f along z-axis fz. The component is unit vector is the k cap along the z-axis. Now the component of this here m is nothing but a scalar quantity, so it cannot be resolved into its components. So I take it as such, but this is a vector quantity, so it is resolved into its components as ax, ay, and aj, like that. Ax I cap plus m ay j cap plus m az k cap. Okay. Now I'm going to compare the terms present in the left hand side with the that of RHS. Okay, that's the right hand side. Let's see what happens if we do so. I'll pick up the term having equivalent or same unit vector. Okay, means fs I cap will be equal to max I cap. Similar way, fy j cap is equal to may j cap. This similar way, fz k cap is equal to m az k cap. Okay, now in all these equations, both sides we have same unit vectors. We want to cancel them. Okay. Because when they are taken to the other side, it will divide and will become 1. So this equation can written as fx is equal to ma x, and this is written as fy equals to ma y, and the third one is written as fz equals to ma z. Now this clearly shows that one vector quantity or one vector equation gives rise to 3 scalar equations. Okay, or in other words we can say one vector equation is equal to 3 scalar equations. This is what we understand from this. I'll go for the next one. Next example I'll take. So p vector equals to 0. Now I'm going to resolve this into its components. So p vector is resolved into px I cap, py j cap, and pz k cap along x, y, and z axis. That is equal to, now I am going to resolve 0, which represents the 0 vector. So 0 I cap, 0 j cap, and 0 k cap. Okay, this is the component of 0 along the x axis. This is the component of 0 along y axis. This is the component of 0 along k cap, that is along z axis. I'm sorry. Now I'm going to compare the terms having same unit vectors. So px I cap is equal to 0 I cap, and p y j cap is equal to 0 j cap. The last one is at k cap is equal to 0 k cap. Now similar terms can be cancelled here. So then what you get is this: px is equal to 0, py equals to 0, and pz equals to 0. This is what the components of momentum along x-axis, y-axis, and the z-axis. This is how one can compare the components of a given vector present in an equation. I hope the video is useful. If you have any kind of doubt relevant to the topic, can you put a question in the comment section? Thanks for watching.